Good morning. Welcome back to my channel. Myself, Professor Sangeeta Gupta, working at Chaitanya Bharati Institute of Technology, Hyderabad. So today we are going to discuss about more details with respect to the blockchain technology. As blockchain is a decentralized and a distributed system, it is necessary for us to understand the significance of a distributed environment. So to start with, a distributed system and its properties. So, a distributed system is a computing paradigm where multiple nodes work with each other in a coordinated fashion in order to achieve a common outcome. It is designed in such a way that the end users look it as a single logical platform. Now, when we are talking about multiple nodes in a distributed system, these nodes can be located physically anywhere across the network. Each node may or may not be connected to the other node in a centralized environment, while in a distributed system, it is essential for the nodes to be connected with each other logically. So let us say if we have three nodes in our distributed environment labeled as N1, N2 and N3. The node N1 is connected to N2 and the node N2 is in turn connected to the node N3. Now, when the node N1 is performing an action, node N2 can also perform an action at the same time. Let me say the time is T1. So at the same time T1, node N2 also can perform its action or any operation, and at the same time T1, node N3 can also perform its required operation. However, this entire system, it appears to the user as a single large system, just like multiple users are trying to access Google at the same time, but it looks to the user as if only one user is accessing the network. So, this will allow the users to operate at the same time, providing a single coherent platform. A node is basically defined as an individual player or the task performer in a distributed system. These nodes are capable of sending and receiving messages across each other in the network. So the arrows from node N1 to N2 indicate that N1 is sending a message to N2, and the arrow in the reverse direction, that is from N2 to N1, indicates that node N2 is sending an acknowledgement back to N1. This sort of sending and receiving messages, it is a common mechanism to promote communication across the nodes in a network. However, there is a possibility for the nodes to either act honestly or behave maliciously. And these nodes are also said to have the memory and processor. So each and every node will have its own storage capacity. Okay, so the memory and processor is associated with each and every node across the network. However, if the node is exhibiting malicious behavior, then it is known as a Byzantine node. So Byzantine node is something which exhibits malicious behavior. What sort of malicious behavior can a node exhibit? If node N1 has sent a message to node N3, okay, asking for some sort of coins or tokens in order to perform or process a transaction. Okay, and N3 is supposed to respond to node N1 within a stipulated amount of time. But if N3 is not responding to N1, then it is said to act maliciously. However, the node may even go off due to the network issues. But if the messages or response is not received back within a stipulated time, then there is a possibility for the node to be called as a malicious node. So such malicious nodes can be identified as a Byzantine node. So usually Whenever we are working in a distributed environment, the number of nodes, they must be in such a way that the number of faulty nodes are less and the system is capable to perform even in the presence of the faulty node. For example, in this equation, n greater than or equal to 3f plus 1, where n is the number of nodes and f is representing the number of faulty nodes. So, if there is one faulty node, that is, if the value of f is 1, then n should be greater than or equal to 3 into 1, that is 3 plus 1, 4. Okay, so that means when the number of nodes is greater than or equal to 4, then the distributed system is having the capacity to survive the failures. It is even having the property to work in the presence of a faulty node, provided the number of faulty nodes. Okay, if it is 1, then node should be greater than or equal to 4. Similarly, if the number of faulty nodes is 2, then the value of n should be greater than or equal to 3 into 2 plus 1, that is 6 plus 1, 7. So, if the number of nodes is more than or equal to 7, then it is able to survive even two faulty nodes. So, this is a property which helps us to work with the distributed systems even in the presence of faults. However, there are various challenges of a distributed system. The primary challenge of a distributed system is the coordination between the nodes and faulty nodes. So, if the number of nodes is, let me say, n1, n2, so on up to n10. If there are 10 nodes in a distributed system, and the coordination, that is the links established between the nodes, are broken due to some network issue, then will the system be able to survive these faults? It is a challenging aspect. It cannot be decided because the number of faulty nodes, it if the faulty nodes are restricted to one or two, then yes, the system could be able to perform. But if the number of nodes is kept on increasing, then it is difficult to predict the fault nodes. Hence, it is a challenging aspect to decide on the ability of a distributed system to survive the faults or failures. Another challenge is uh, if the distributed system is able to survive consistency and availability, will it be able to work well even for partitioning of nodes? So this is something related to the CAP theorem. So usually a distributed system, it cannot achieve all the three properties at once. Either it can provide consistency and availability, or it can provide consistency and partitioning, or availability and partitioning. But all the three properties cannot be provided at once when we are working with a distributed system. So though distributed system is having various advantages, it is also associated with a set of challenges with it. However, it is an essential environment to be learned when we are working with a blockchain system, because a blockchain is something which is built over a distributed system. So thank you, and I request you to please like, share and subscribe to my channel. We'll meet shortly in another video.